Nice to see you all. Today I will go through our quick start instruction and join new node to the Gonka chain. Let me share my screen. Yes, to show the whole procedure without waiting for new epoch, I will join new node to testnet. It's just faster, but the process is exactly the same. So we will go through this instruction, host Quickstart, and actually, yeah, just simplest pipeline when new node with network and inference node at the same device. So yeah, okay. So to show, we have this small testnet on this address. Let's open the dashboard. Yeah, 3 nodes, and let's add one more. Okay, so let's start with Quickstart. Each deploy of Gonka node has two fundamental parts. First one is network node, is couple containers, which actually part of blockchain, which communicate with another nodes and record data. And also inference node, which has GPUs and which actually does the compute. So we today will deploy they both together on single machine. I rented some cloud machine with NVIDIA H100, 80 gigabytes. So yeah, it's here, it's live. And yeah, so they both will be deployed together, and let's start. So first of all, this instruction is saying how you can organize your node if it's big, how you should choose which model to deploy to optimize your reward, and etc. Let's move to the deploy itself. So there is requirements to the machine. Each server has to have 60 core CPU, at least 64 gigabytes of RAM, and 1 terabyte of SSD. Each ML node also should have quite a lot of RAM, and also the important part, each should has NVIDIA Container Toolkit with versions between 12.6 and 12.9. Then we here describe which ports should be opened at this machine, and we recommend to close all another ports and have only this three opened. Yeah, and right now our node has all this, our server has all this already set up in advance, so it's a CUDA version 12.8, and it has required ports opened. Okay. Each, when you create new node, it has multiple keys, security keys. There is a page with detailed description, but what is important is that each node and account has its own account code key, which should never be on your server. This key should be only locally, and all your reward and your coins is stated with this key, and to vote for some chain decision or to transfer money, you will use that key. That should be local. It's important. But at the server itself, there's a worm key, a mail operational key, as we name it. That key can be quite easily replaced, and it's just signing automatical transaction which network node is doing. And yeah, so that's already should be on server and can be easily replaced and don't have access to your coins. So yeah, let's start and create this key. First of all, we have this link to GitHub releases. Let's download the CLI tool for Gonka. I have Mac, so I should download this file. Okay, let's unarchive it. And so yeah, this is our directory for demo. Let's copy it here. Now let's make it work. On Mac, it requires some permission to run custom binaries. Let's do it. Let's try to run it. Okay. So we go to security, system setting, privacy and security, and allow running custom binaries. Let's do it once again. Open anyway. Okay, so yeah, our Gonka CLI is working. What's next? Next, we creating account key again, only locally. Let's do it. Okay, we should use some password. And when we create key, what is really important here, we have the secret phrase. And this phrase should be stored somewhere pretty privately, maybe just on a piece of paper. And if you lose access to your key using this phrase, you can recover it and you can return your access. That's kind of really important. Right now, I'm showing it on my screen because it's only demo and it will not be real coins on this account, but you should never show this phrase to anyone else. That's important. Okay, we created our account key. Now let's start to work with server. So we copy this command. We go into our server and we are cloning the repository. Okay, repository. Oops, I'm sorry. Okay, repository is cloned. Let's and next step would be to set up our environment variables to deploy. Here we have template for environment variables file, config.env.template. Let's copy it and take a look on our config file. So that's variables which we have to set up. And on website, we have some more detailed explanation, which one, what means. And yeah, right now, I will also change additional variables, which are point to seed node and which are point to RPC servers. Why I'm doing this? Because we are connecting node to testnet, not mainnet. You can use the default values or any node of the Gonka chain which you think worth to be used as seeds. Okay, let's start. Again. We should first set key name. It's just the name of local name of a mail operation key which will be used. So let's say demo key one. I don't know. Some again local password. We can use everything here. Then public URL. We will use static API of our node, not of our server. Let me find it. Yes, that's static API of the server, and our deploy will be at API port 8000. So yeah, this public URL will be used like main entry point for any inference. P2P external port is every time at the same IP, but the port is 5000. So everything is described in Quickstart. Yeah, then we should pass account pubkey, and we just created it, and yeah, so this is information about our account, address, name, and pubkey. Let's copy key. Okay, pasting it here. This is directory which will be used for Hugging Face cache. Let's use home there hf cache. Okay, and as I mentioned, we will use our testnet. So let's pass seed nodes from testnet. Okay. Okay. Okay, and one more. Okay. So these ones don't have to be changed on when you join mainnet. Okay, let's go to the next step. So we just finished step edit environment variables. Let's load them. Then we should decide which models our node will deploy. And this is that one. So we should edit node.config.json file. Node.config.json file is file with initial models which will be deployed, and then you can modify models which deployed on your node already when node is working with API. Okay, let's take a look which models are available on testnet. You can use such command of CLI, inference models all, and okay, yeah, we have this default model with a bit different parameters. So the list of model might be changed by chain quite often. Okay, okay, okay. So yeah, we configured model. Now tells now we should download model weights to hiding face cache. So first let's create directory with cache. Yeah, yeah, this directory. Then let's downloading it with hiding face CLI. First of all, we need to install hiding face CLI and let's create environment, Python environment for this. 1 second. Okay. And then, okay. And we install hiding face CLI. And then downloading the model we chosen. Okay, I forgot model. Okay. Yeah, model is downloaded. And I forgot on one modification. So as again we are launching Node at testnet, I want to disable snapshot. It means it will just reproduce all blocks and you don't have to do it on mainnet. Okay, source config.him. Okay, and now we starting to launch containers. First, we are pulling them using this command. All containers are downloaded. Then we are starting 10KMS service and not container. This service will be responsible for signing blocks. Okay, then let's just double check that everything is good and we can take a look on logs. Okay, we made a mistake. Okay, 1 second. Okay, let's double check. We can easily exit. Okay, get TN. Well, job address, notes. Okay, let's just try one more time. Okay, yeah. Container just created a bit later than canvas. So yeah, everything is good. We can see that we got up chain and we in sync. Okay, and we see that right now there is a proof of compute phase at main chain. Okay, let's go to the next command. Now we should create a mail operation. So yeah, once again, what we did now, we started just base container, which right now just listening our testnet. And right now we will start API container, which actually communicated with ML nodes and which responds to inference request. Okay, starting the service. Okay, and this command is used to automatically create our worm key. Okay, it's created. And then this command can register our new participant at blockchain. Okay, we see that this new participant is registered and we can actually see it. Yeah, this is our new participant. Okay, let's go. So we are exiting from container. And then at local machine, we should grant permission from our account key to our worm key. There's a comment for this. Let's open our local machine. Okay, so what we should use here, address of a main operational key, which we just created. It's right here. And also seed API URL. What was our seed API URL? We can take a look at it at config.env. But not. Okay. And now we just using this command. It's ask for password. Right now it's sending transaction with granting permissions, and transaction is recorded. It's awesome. And then we can ready launch node. Okay, so launching all containers. So it's going good. Let's take a look. The process again, node is registered. Now we should check that API container, which we just started is working. Yeah, so this is how to check if chain container is working. You can see current latest block and it's moving. And in the same way, like we check logs for node container, let's check logs for API container. Compose logs API. Okay, we see that it's on the same pace, same height, and it will participate in the next proof of compute phase, and then it will be active participant. Okay, 1 second. I also want to show you what is going on inside the GPU container right now. So yeah, we didn't have time to participate in proof of compute phase. It just finished before we joined, and then it's just waiting for the next one. Yeah. Okay, I think we finished, and our note will be visible here after next proof compute, which will be in, I don't know, 15 minutes, something like that. And yeah,